Hello, everybody. It's Mr. Vallejo. We're here at the Gorman Learning Center in Southern California, a charter school that is online and has satellite physical offices located throughout Southern California in the Antelope Valley and San Bernardino and Redlands and Canyon Country and all places like that. All right, so today, you guys, we're going to take a look at the practice problems in chapter 16.2 of the Pearson Chemistry book. It has to do with concentrations of solutions. So as we often do, I'm gonna share my screen with you and then solve some of the problems with you. Okay, so let's do that right now. Okay, so again, this is these are problems. What do we call these? We call these the sample problems. So these are the sample problems, and from 16.2, we're gonna. The assignment is to do all of them. We're gonna do the selection of them. So this is numbers 10 through. Let's see, 18. And this is found in pages, ends in 531. It starts on 526. Okay, so here we go. Let's take a look at them. If you have your book, that would be most handy, because then you'll be able to see the questions as we we'll be able to see the question as we solve it. But I'm going to drop my textbook and then we'll pick it up and turn to page 531. But before we get started with that, actually, one thing that is in this section has to do with molarity. And you need to know that molarity is a value that is equal to the number of moles of the solute divided by the volume. Okay, so whenever we have if you take a look at the units, you know, if you're doing like dimensional analysis or canceling of fractions, if you come up and your final units are moles per gram, moles per liter. The liter is a volume. This is the unit of molarity. Your textbook will probably often write this moles per liter, but that's because that's an easy way to type it. But really, we want to see it in a fraction that's vertical like that. Okay, so that's molarity. Now here's a trick we often teach you in an algebra class, but it'll work here. It's called the magic triangle. For those of you whose math skills aren't where they should be, we have kids set up a triangle, and so it works like this. Molarity, which is a capital M. I'll just write it. Molarity is equal to moles over volume, right? But if we write it this way, in the magic triangle, we have moles, or molarity is equal to moles over a volume, like that. So sometimes we call this the magic triangle. And that's because for those people who don't have great algebra skills, this gives them the ability to solve it. Because like if you were trying to solve for molarity, what you could do is you could cover this up and say, oh, I'm solving, out of these three, I'm solving for molarity. So what I would do is take the number of moles and divide it by the volume. Let's say I wanted to solve for volume. How many liters do I have? Well, then the information you need is moles over molarity. And then similarly, if you're trying to figure out the number of moles, then if you know molarity and volume, you could multiply those together and get the answer. So, woo, the magic triangle. But really, you should be able to isolate a variable on one side of this equation anyway. Like, hopefully you recognize that if you were to figure out volume, you could swap these, and then volume is equal to moles over molarity, just like you see in the magic triangle. Okay, so that's some background stuff to know for solving these questions in 16.2. So let's take a look at, I need to go back. Remember, I dropped my book on page 526. So on page 526, I'll show you the question, but then I gotta move this out of the way in order to solve the question. So there's the book, and then here's question number 10. Let's read it together. It says a solution has a volume of 2.0 liters and contains 36.0 grams of glucose. And then they give you the formula. If the molar mass of glucose is 180, and you should be able to figure that out anyway. But if the molar mass is 180 grams per mole, what is the molarity of the solution? Okay, so the question is, what's the molarity? So we've got to figure out in question number 10, we want to figure out what the molarity is. Okay, so what did they give us? Well, here's what they gave us. They gave us the solution has a volume of 2.0 liters. We know that there's 36 grams and 3 Sig Fig of sucrose, which is, oh no, I'm sorry, it's glucose, which you should know is C6H12O6. Okay, so, and so that would be mass. But then remember, they're telling us that we have a molar mass of 180 grams per mole. Okay, so your molar mass is 180 grams per mole is the molar mass. But then what we want is the molarity. All right, in order to figure out the molarity, you got to figure out the, let's see, you got to use this information up here to figure it out, but also always start with what's given to you. So we have 36 grams of glucose. Let's start with that. They said there's 36 grams of glucose, C6H12O6. And that is sitting in 2 liters. And that's your, it's 2 liters of water is the assumption. Okay. But what we want to figure out by the time we're done, when we get the molarity, is moles over liter. Well, we've got the liter on the bottom, which is what we want, but we need moles on top. Fortunately, what they did give us was they gave us 180 grams. Oh, you can't see that, sorry. All right, so what they gave us is 180 grams per mole, okay? Now, if you have 180 grams per mole right there, the molar mass, well, if you put the 180 on the bottom, that'll cancel your G, 180 grams for every mole. And lo and behold, remember your answer, you want your answer to be in moles per liter. And so if we cancel out the grams, we're gonna get moles over liter. So we get the calculator out. then what you can see is, let's see, there's the calculator. I got 36. I need a new screen protector because it's got a little bubble and sometimes it doesn't take. Divided by 2, divided by 180 equals, and your answer is 0.1. Now let's look at Sig Fig real quick before I put the units on there. Significant figures, 2 there, 3 there, 2 there. So let's go with 2 Sig Fig. This is only 1, so I'm going to put a 0 right there. And so our answer is 0.10 moles per liter. Moles per liter, which is also, if you wanted to, not required, but if you do it this way, you can see that there are 2 Sig Fig times 10 to the negative 1 moles per liter, or molarity. Now, if I write moles per liter, I think that's pretty clear. But if you want to just write a big capital M right there, that is the way you would abbreviate molarity, which comes in units of moles per liter. So that's number 10, 0.10. We check the teacher's answers to make sure we got it right. Oh, good, we did. Okay. Remember, they never show me how to do it. They just show me an answer. They say, okay, hope you got this. And we did, so we're doing all right. So that's 10 milliliters, or 0.10 moles per liter. That's the answer to number 10. Cool. All right. So let's go to the next page. And that's on page 12. You got 527. Okay. On my page, go to page 12. Different type of question. It says calculating the moles of solution in, or moles of solute in a solution. Okay. Moles of solute in a solution. So you go to number 12. Number 12, I'll show it to you again, but hopefully I remember to pan back out. Here's number 12. Number 12 says, how many moles of ammonium nitrate are in 335 milliliters of 0.4525 molar ammonium nitrate? Okay, so there you go. Let's take a look at how to solve this problem. Remember, always start with what they give you. So what do they give us? Well, let's see. We have moles, or that's what we want. We want moles. Moles of ammonium nitrate are in 335 milliliters of 0.425 M. So molarity is 0.425 M. And then the volume is 335 milliliters. Okay, so that's what was given to us. So we're trying to get to moles, right? So let's go ahead and set this up. You have 0.425 moles in, and remember the molarity is equal to the moles over the volume. So we can say we have molarity is moles, 0.425 moles. And that's going to be, let's see. And we have 335 milliliters, but let's see. moles of ammonium nitrate are under 335 of 0.425. Okay, so we have, they're giving us the molarity, which is 0.425 moles in 1 liter. Okay, but what they've given us is a volume over here of 335 milliliters. So we need this in milliliters, but we need to cancel out the liters first. So you also know that in 1 liter, there's 1,000 milliliters. Okay. And you need to be able to cancel out the milliliters, which is 335 milliliters is what was given to you. So if we take a look at what we're canceling, then we have liters canceled, we have milliliters canceling, and then you have moles left over, which is what we want. So really what we did was we're going to multiply 0.425 times 335 and then divide that by 1,000. So let's do that. Get out my handy phone and go to the calculator. Clear that last problem, 0.425, oops, 0.42, not reading the 4.425 times 335 divided by 1,000 equals, and the answer is 0.142375. Okay, so that is 0.142. 3 Sig Fig, 3 Sig Fig. Let's put our answer in 3 Sig Fig. So what you have is 0.142 moles. Moles of what? Moles of ammonium nitrate. And you could also write ammonium and then nitrate, NO3, and that would be your answer. Okay. So always start with what they give you. And then when you get to the units that you need, then that's where you are. That's what you need. And that's where you go. So that's number 12. All right. We have 6 different types of problems here. So tell you what, I'm going to go to the next one, which is on, let's see, which is number 14 on page 529. So here's number 14, and it's on page 529. The question reads, and I'll read it for you this time, how many milliliters of a solution of 4.00 molar Ki are needed to prepare 250 milliliters of 0.76 molar Ki? Ooh, all right. So that looks pretty deep. But before we do number 14, you need to take a look at the reasoning behind it. And what we have to do is manipulate this formula. Remember, we have moles, or molarity is equal to moles over volume. Now, if you're trying to find moles of solute, then moles are going to be molarity times volume. But if that's the case, then we can know that if we have two different solutions, M1 V1 is going to be equal to M2 V2. And we can cross multiply and use that to figure this out. Okay. Tell you what. Okay, so let's take a look at 14. And remember, the chem problem, what you want to do is you want to start with what they give you. So the question it reads, how many milliliters of a solution? So that is going to be the first one that they mentioned. How many milliliters of a solution? So that's V1. So what we're trying to figure out is V1. Now, one thing you can do is before you even mess with the numbers, you can solve this equation for V1. So if we do that, hopefully you can see quite easily that all you gotta do is slip this M1 underneath this, because what you gotta do is you divide both sides by M1 to get to the V1 by itself. So if I do this and go M1 and put M1 there also, and you can see that the M1s are going to cancel. And if I clean this up, what I get is V1 equals M2 V2 over M1. Well, I haven't even defined anything yet, but let's look at the equation over here. And we'll say how many milliliters of solution, milliliters is a volume, of 4.00 M, 4.00 M, and that is a molarity, and that's the first molarity, so that's M1. Okay, so then they continue and they say are needed to prepare 250 milliliters, so that's going to be our second volume, 250 milliliters of what? Of a molarity, so that's going to be M2 of 0.760 M. Okay, 3 Sig Fig all the way across. V1 is equal to that, and so we just plug everything in. So M2 is going to be 0.760 M. We have V2 is 250 milliliters. And that's all going to be over M1, which is 4.00 M. The molarities are going to cancel. Your answer is going to be in milliliters. Okay. And if we get the calculator out, what we're going to see is, let's see. Okay, there's the calculator. And then there's the problem right there. We have here 0.76 times 250, 0.760 times 250. Again, my 2 isn't working. 250 divided by 4 equals 47.5. So that is the answer, 47.5 milliliters of the solution. Box your answer. You've shown your work. And that is how we do number 14. Okay. All right, there it is right there. I'm going to show you the answer by blocking out the sun. Okay, 47.5. So that's number 14. Let's go on. And I don't know, do you need to take a screenshot maybe? Some of you still writing? Okay, that's good stuff. Good technique to do it, to don't even mess with the numbers until you solve, if that's a possibility with any problem that you have when you're working in chemistry. All right, I'm trying to play with the shadows here, see where the best place is. So let's scoot myself over and move some stuff out of the way. It's still not great. Okay, so it's a little better, but now I'm out of, now I'm in the picture again. All right, so that was what, number 14? Let's do the next one. Number 16 on page 530. 16 on page 530. All right, here we go. And there it is right there. You have 10 milliliters of propanol. That's C3H6O, also called acetone. It is diluted with water to a total solution volume of 200 milliliters. What is the percent of volume of propanol in the solution? All right. So you start with what they give you, and then try to figure out how to manipulate the equations, and then solve for it. So there it is right there. Hopefully you have your books. If not, there's a question. Don't know if you need to take a screenshot. If you do, go ahead and do that. We're trying to figure out the percent by volume, and the percent by volume is going to be the volume of the solute divided by the volume of the total solution. Okay, so that's how you get that. So let's go back and write down what is given to us. So what we have is, and let me go up so you can see the whole paper again, and sun is creeping through. That's a good problem to have in Southern California. A lot of sun. 10 milliliters of acetone. So it's 10 milliliters, which is the volume. 10 milliliters of acetone, C3H6O. 10 milliliters of that is diluted with water to a total solution volume of 200 milliliters. Okay. What is the percent by volume of propanol in the solution? Now, careful with this one. Remember, and here's the formula. It's the volume of the solute divided by the volume of the solution. And then you got to move the decimal point over because it's a percentage. Okay, and that's all they gave you, actually. So this wasn't a very complicated one, but just so you know, we often abbreviate this volume because they're both volumes. If you were shortcutting it and abbreviating it, you might write an S right there, like a sub S for volume of the solute, volume of the solute, and over here you would write the volume of the solution, which was the total. So I'm going to put TOT for total. So you can see that's 1 over 20. 1 over 20 is 0.05. You have 2 sig fig, so it's 0.050. But let's make sure that we show you on the calculator, because I just, excuse me, did that one in my head. So, excuse me, 0.050 is going to be 5%. But since it's 2 sig fig, we would write 5.0. But let's show you all that. VS equals V total. So that's 10 milliliters over 200 milliliters. Punch that into the calculator. 10. I wasn't going to change this screensaver, but now I'm probably going to do it tonight. 10 divided by 200 equals 0.05. Okay, but it's a percentage. So move this over, which is the same as multiplying by 100. So I'm going to get 5.0%. Okay, so that's the answer to number 16. Okay. And that is, that's a percent by volume. This book actually uses an abbreviation for that. Where is it? Oh, they call it V over V. So you could write it like that, as the answer, 5%. Okay. So that is number 16. Right there, it's a little bit better. Sun keeps moving. All right. And then we only have one other type of problem in this problem set. So let's go to that last one, which is number 18. All right, 18 says calculate the grams of solute required to make 250 grams of 0.10% magnesium sulfate. Okay, so, all right, let's start with what they give you. What they want is grams of solute. So the mass of the solute is what they want. Okay, and you've got 250 grams total. Total mass of the whole thing is 250 grams. Okay, and you have a 10% MgSO4 magnesium solution. Okay, so let's see. I would say what you need to do is, well, you know the percent by mass. And oh, I didn't write that down. The percent by mass, which I bet you they call M over M, is going to be 0.10. Okay. So let's see. So we have 0.10%. Let's figure out what we're trying to do here. We have, let's go ahead and write the percent by mass as a conversion factor. So if we have 0.10%, that's going to be, let's see, 0.10% is going to be 0.1 grams in 100 grams. So this is the mass of the if we express this as a conversion factor, that's at 0.1 grams of MgSO4. MgSO4, and it's going to be 100 grams of the whole thing, of the whole solution. Okay. Now you had to distinguish between grams of magnesium sulfate and grams of total solution, but this is a conversion factor, and this is what's given to us right there. Okay, and what else did we have? We want the grams of solute to make 250 grams. So if we, all right, so if we have 100 grams of the solution and we want to make 250 grams of the solution, then we want to know how many grams of solute you got to have. So by cross multiplying, what you see is that there's 100x is equal to, we have, what I did was I cross multiplied that way, and then we're going that way. So we got 200, 250 times 0.1, and you should know that that is 25. So I have 0.1 times 250, okay? And this is going to be 25, but then 25 over 100, because I've got 100 here. So if I divide both sides by 100, then I'm left with X. And this is going to be, I'll just do it for us, 0.1 times 250 divided by 100 equals 0.25. And this is going to be grams of MgSO4. Okay, so that is the answer. I box that, and that's how you get that one. That it seemed like they didn't give us enough to work with. And if you remember that the mass to mass, which is the same thing as volume to volume, right? That same principle. Then you could figure out by proportionality, you can cross multiply if you set it up like that. Okay, you have other problems like this. You should be able to now do the second problem of each of the sample problem sets. There's 6 of them. Actually, we already did 16.1 last time. So you have problem sets or sample problem 16.2, starting on 526 over to 16.6 on 531. So hopefully you can do some of those, and with the information that you now have, you can solve those. So tell you what, let's stop this screen share and pause or stop the recording. Wow, the sun is crazy. The umbrella broke out here, so I ordered a new umbrella. It's coming like March 1st. So I think it'll be here before I see you again. Hopefully I won't have any more of these sun problems. But anyway, let's see. It is now 1:03. Why don't you try some of these problems, the rest of them, the ones we haven't done, and do those on your own. And then we'll come back and, I don't know, how much time you want? 15, 20 minutes? 15, 20 minutes. Let's see, 03. Let's just say 15. Come back on 1:15. We'll see how you did. Maybe you got a couple of them done by then. Maybe you finished all of them by then. And then we'll talk about it a little bit, give you a little bit more time, and then we'll do some of the next set, which is 531. Because really that's essentially all we have left in this learning program, and this what do we call it? In your learning program for the learning period. I don't know why I still fumble with all that. Anyway, okay, so 1:15, come back with some more of these solved. We'll take a look at it. We'll answer your questions, and then we'll give you time to start 531, and then we'll actually do some with you. Okay. If you're done with everything by 1:15, and you're still, or before 1:15, and you're waiting for us, just go ahead and start at 1531 if you'd like. 16.2, numbers 19 to 27. Okay, see you in a little bit then. We'll see you at 1:15.